Good afternoon, everyone. I'm Beau Simensen, and I'm going to be talking about my experiences using CQRS and event sourcing to build an MVP. In case anyone who doesn't know CQRS, CQRS stands for Command Query Responsibility Segregation. And the best way to really understand what CQRS is to look at a diagram. The way that web developers have traditionally worked with models is with one model, usually coming out of a database of some sort. Sometimes SQL databases, sometimes NoSQL databases. With CQRS, the idea is that there are actually two models. There's the main model that you send commands to, so that's the right part of the application. And then there's a read model. Is this not working? All right, does this work better? Okay. Wasn't prepared to be holding the mic, but all right, here we go. To go back a little bit here, in case people weren't able to hear it, CQRS stands for Command Query Responsibility Segregation. And how it compares to our traditional model of dealing with data from one model from a database is you have two. You have a normal model like you normally would, but you would only send commands to it. You would be only sending writes. You would have a second model that would represent the read model. The other interesting thing about CQRS is often you can consider both of these coming from different sources. So you might be able to store the read model in a NoSQL store and the regular model in some sort of flat file or in some sort of standard relational database or NoSQL. Event sourcing, if you're not familiar with it, is sort of like what you would see with a bank account. With a bank account where you have money in an account, it's probably not going to have a field somewhere that says balance. There might be some caching involved to show you your balance, but really it's not going to trust that as a source of truth. What you're going to see instead is a series of events, and in like an accounting package you might see these as journal entries. So for example, you might start with an account opened event that says the account is opened with $100, so the available balance is now $100. If you wanted to deposit more money, say $150, you'd have another event that says funds deposited, $150. At this point now, the model or the event stream would be able to calculate the total available balance as $250. You could withdraw funds, and you could withdraw too many funds, and then you would be able to calculate that you have a negative 21 balance, and you would also have an event in the stream that says account was overdrawn. And one of the interesting things once you start looking at DDD and looking at event streams and event store, suddenly you start to see events everywhere. And that's kind of the problem that I fell into. And we lost. Connection lost. Awesome. Did this happen earlier? No. All right. So I'm not sure exactly where the slides dropped off. Did it just drop off, or did you see the different events coming down?
The events were there.
Okay, the events were there. All right. Awesome. So you can get a general idea that with event sourcing, the idea is that all of the persistence is in actual finite little bits. So you're not going to have the final state. You're not going to have like a database record that has the total value. You're going to have individual events that add up to the total value. And the nice thing about that is that you can look at things over time within a given object, and you can also do things like find out why things have happened in a certain way. Yeah. All right. So the general idea with event sourcing and CQRS together, which is what you'll often see, is that it's actually a good way to connect the two different types of read models and models with CQRS. With the event stream, the model side becomes the events, and then the events can be played into a projector, which then can create your read models. So the whole idea there being that the CQRS can be implemented by adding event sourcing for your model persistence. MVP, of course, means minimum viable product. So this is the idea being that you don't want to shoot for the entire application right away. What you really want to get is an application that has enough information, enough functionality that users can at least start using it safely and providing at least a little bit of value. So the idea is trying to get something to market as quickly as possible that actually sort of goes in the direction of what you're trying to get in the end, but without having to get everything perfect first. The project that I was going to be working on was originally pitched as a fintech project, which sounded pretty exciting to me. It was going to be heavily accounting focused, and it was going to have a lot of big data work as the project progressed. It wasn't actually how it ended up happening, but this was what it was initially proposed to me, and I was really excited about it because it seemed like this would be a really good use case for some of these technologies that I've been kind of exploring and playing with on the side. This was going to give me a chance to actually try to put these things into actual production use with actual users. So what we decided to do was break the project up into different pieces just to figure out what we were actually going to do. We decided to break the project up into 3 pieces, CRM, accounting, and big data. And rather than trying to go straight into accounting or big data, we decided to start out, at least initially, with the CRM pieces, because that could give us the base that we would need to build the other applications around it. Yay! So all in all, if you're looking at building a CRM, you might not actually want to build event sourcing into it at that point or CQRS. However, it was going to be such a huge part of our application shortly after MVP. This is one of the reasons we considered actually doing it for a use case that might not have been perfect for that situation. And that first piece that we were going to build was the CRM. So our criteria for building our MVP was we wanted to provide an address book with a list of contacts. These list of contacts would be very important within the accounting system as they'd be attached to every basic component within the accounting system. So whether we're sending credit notes, invoices, anything along those lines, they would need to use the address book. We also wanted to build deals into the system, just a way to manage some deals so that people would have an actual reason to use our application before we could actually get to the point where we're building the accounting system. The person who was founding the project, who came to me, had experience with a previous project that he'd worked on, and they had to rebuild the project every 2 years. So he really wanted to start out from the very beginning with a solid foundation, a really good architecture that could last, so that it could at least be extended rather than having to be rewritten every 2 years. But at the same time, we also wanted to be able to jump on the features quickly so that we could actually move really fast. Right out of the gate, we needed to be multi-tenant. So this is something that would be great to not have to have in an MVP, but being as we were talking about working with companies with multiple users in the system, we needed to have some sort of multi-tenant functionality built in from the beginning. One of the things that I added to the mix was I wanted to see us have a single page application. Since we were building something that was going to be used by businesses, I wanted it to be snappy. I wanted it to be something that people actually enjoyed using. So this was something that, if we could make it happen, I wanted to see if we could do this. So looking at the stack we came up with, I wanted to find some sort of Flux architecture for the JavaScript side. I ended up choosing React and Redux for that. How many people have used React? How many people have done Reduct? Redo? Okay. I also didn't want us to have to worry too much about the UI. We could have gone with Bootstrap, but at the time I thought material design would be an interesting thing for us to try. There was a React component for Material UI that we used, or a React library called Material UI that we used so that we didn't have to build any of that stuff ourselves. We decided to build our own internal framework. There were a couple of things that we tried to look at, and nothing really seemed to really fit with what we were trying to build quickly. We wanted to do just basically an API first sort of thing. So we decided to put together some pieces to do that on our own. And we also decided to build our own internal event sourcing and CQRS infrastructure. So now might be an interesting time to discuss the team. There was me. There was someone who I'll call the Cowboy. He was actually an incredibly good developer. I don't want to say that he was bad by any means, but he was the type of person that you say, go do this, and he would go do it no matter what. He wouldn't ask questions. It would get done, but you never knew exactly how it was going to get done or whether that was how it should have been done. So he was the type of person that the founder of the company really liked, because the founder could say, go do this, and he would go do it, and a day later, 2 days later, it was done and worked. And sometimes, we'd have to do a little more work to make sure that it actually worked, but he was a really good resource for us because he could get work done very quickly. We also had someone who was quite junior, and by junior, I mean this person was actually a sales analyst before he started programming with us. And by far, this was probably the best part of this whole experience with this project for me, was working with this person, because he went from basically no information knowledge at all about how to build a PHP application to writing complex React components that were amazing. So he really, really, really became important for the team. And that was the team. That was the three of us. So we were going to build this single page application with event sourcing and CQRS with a Cowboy and somebody who was a sales analyst with me. So one of the things I wanted to do was do testing. Of course, neither of them had done any testing whatsoever. The more advanced developer had done work with Laravel, but was mostly a WordPress developer. So no testing at all. I wanted to make sure that we were doing modern PHP so that we didn't have to worry about some older things. So everything was brand new that we were using. We were using new components that were following standards where appropriate. And then we decided to build the event sourcing and CQRS infrastructure from scratch. But we did it as a team. And I think this was probably one of the really big wins that we had, because this gave us a really good opportunity to work together to figure out some of these more complex topics and actually get them to the point where they understood what was going on behind the scenes, rather than just extending the right class and it just works by magic until it doesn't. So I learned some important lessons. One of my friends, Dave Marshall, occasionally gives me little nuggets of wisdom, and he shared this link with me one day just randomly. Choose Boring Technology by Dan McKinley. And to be clear, the idea isn't that boring means bad. It just means things that you are going to be mostly okay with, that isn't going to be new or different. And that any project should probably have 3 innovation tokens. So if you're looking at something that is outside your knowledge or outside the team's knowledge, that would be an innovation token. And then you could decide whether or not it's really far out, and you could say that's 2, so maybe we could do something else little that's new. But basically, you shouldn't go more than 3. So if we look at the pieces that I picked React. It's probably 1 token if you're already familiar with like Angular or some other JavaScript framework. But for our team, it was probably 2 to 3 tokens just for React. None of us had really worked with React before. One of them had done jQuery, the other, of course, hadn't done any programming. So probably React alone probably would have been enough for our team to try to do different here. Redux, same thing. For our team, probably this was not a good pick. Material UI turned out to be a nightmare for us. Sure, it worked for the most part, but it had a very fast life cycle, and they were breaking backward compatibility all the time. So we ended up spending a lot of time trying to reverse engineer how they were building stuff, and it was just not very good at all. Event sourcing is actually almost maybe a boring technology in many ways, because it's something that is sort of new and it's kind of a fad in PHP and broader software circles right now, but it's something that people have been doing in banks for ages, and different domains have been using things like event sourcing. But for us, this was very new, this was very cutting edge. There were no really good examples of this in PHP that were really stable and used in production, so this was not something that we probably should have taken on. CQRS, same thing. This is something that is really, it's doable if you're going to try and add CQRS to your next application. It's probably going to be 1, maybe 2 tokens, because it's going to be new enough that you're going to have a little bit of head scratching. I wanted to use PSR7, and I thought that this was actually going to be difficult to do, but this turned out to be quite boring for us. PSR7 turned out to be a really good way to build a micro application that was just serving API requests. PHP, of course, would be considered boring. If someone decides they're going to build a new application in PHP, no one's going to say, oh, don't do that, that's cutting edge. MySQL was pretty boring. We decided to use MySQL for everything. And this was more a fact of trying to not have too many different services in the mix. They were working on Linux boxes. I was working on a Vagrant box on a Mac. Really, if we had MySQL to do everything, until the point that MySQL could no longer keep up with it, we decided to implement everything with MySQL. And for deployment, we were using Envoy and Forge, which were really easy to do and hook in. I'd already used it before, so deployment to production, deployment to staging was really easy. So looking at our stack, best case, based on this original article, we're maybe looking at 5 tokens. This would be if we were already pretty much experts at these things, but for our team, it was really closer to 10 to 15 tokens worth of unknowns. So at the end of the day, what happened was it took us 6 months to get to our MVP. And depending on what your idea of an MVP is, 6 months is or is not a good number. But really, when I look back on it, it probably took us way too long. If we decided to build this on any out-of-the-box framework, whether it be Symfony or Laravel or any Zen framework or even Zen Expressive, we probably could have built this with standard HTML templates in about a month. Now, given that we had the goal of wanting to have a solid framework, that wouldn't have made as much sense. What we ended up with was a really good, solid foundation for our application. It just took us longer to get there than it would have otherwise. But at least given the original specifications, that was actually was a desired outcome. It did feel like a desktop application. It was actually really cool to see that. I've used some of these applications that are web applications online. We just click around and everything just happens. It's amazing. And this was actually starting to feel that way. When we wanted to click around through things just were snappy. It was all API driven. It was really amazing. And then 6 months later, we threw in the towel on the project entirely. So there were some important business lessons that I learned or relearned as a part of this. But one of the things that kind of had me for a little while was this my problem? Was this my fault? Did I cause this to happen? Was the stack that we chose, we/I chose, going to be the reason that this was going to go down? But really what the problem was that 2 weeks after we finished our MVP, the founder said, hey, guess what? We're just going to build a CRM. We're not going to do those other things for like 3 or 4 years maybe. We're just going to be a CRM. And this was probably the beginning of the end for us. The business reasons why was that the sales and marketing team couldn't actually sell the product. They couldn't sell this simple MVP CRM that we built based around technologies that were not suited for just building that kind of application. The CRM market, if you're not familiar with it, is super saturated. It's very competitive. There's a lot of different people doing a lot of really cool things within the market, and we just had no way to compete, especially with the application that we had built that was really just intended to be a simple module for a more complicated package. If we'd known sooner that the sales team and the marketing department weren't going to be able to deliver on a CRM, we probably could have saved a lot of money. We would have saved a whole year's worth of development time. We would have saved so much more money just even thinking about, are we going to build more features? What are we going to do? We could have known within 1 to 2 months after the MVP was completed that, yeah, this isn't going to work. For me, this was sort of a catch-22 though, because really, if we were going to build a CRM from the very beginning, I probably wouldn't even have gotten involved. It was not something that I wanted to build. It wasn't the project that was pitched. And the whole architecture, the entire technology stack was wrong for building a CRM. There were some cool things that came out of it though, as far as like learning about different technologies and trying different things. One of the projects that we built into it was a custom serializer that just looked at the properties on an object. The main reason we did that was that most of the CQRS frameworks that were out had weird serialization things, or trying to use like Symfony Serializer or something like that, where a lot of configuration was needed. We were building like hundreds of events, and we didn't want to have to keep writing all the serialization logic for those. So this turned out to be really good early on for DX. But after about 3 months in production, things started to get a little slower. So it was a good way to jumpstart us into this project without having to spend a lot of time on configuration. And then once we were at a point where we needed to actually fix it, we would have been able to fix it pretty easily. One of our read models that turned out to be one of the most interesting and most used was our search read model. The search read model ended up having all of the information for all of the core objects that we'd created, mostly people, companies, and deals, so that it was really easy to look them up. There's a lot of ways you could do something similar to this, but this just was building on its own in the back end. So you really didn't have to think about it as long as you were building the projectors correctly, it just worked. Initially, we started out with a history read model for our objects. The history read model was very rigid, so it didn't really work very well. It felt more like an audit log. So we could have actually done similar functionality with just a traditional audit log rather than trying to do something with event sourcing and CQRS. But we didn't use it for very long. What we ended up doing was building a timeline read model. And the timeline read model, we kind of changed the way that we did things and the way that we stored the events for the timeline itself based on the events that were actually coming from the rest of the system. So it really showed the full power of event sourcing CQRS, because we were able to do some really interesting things with the timeline, being able to show different views of the same data within the same read model. We designed the whole system for async, but we never actually implemented it, so we didn't actually ever have to worry about any eventual consistency problems, which was actually pretty nice. We were getting to the point where we might have needed to by the time that the project went away, but we never actually had to worry about this problem. One thing we learned really quickly was that events change. This is one of the questions a lot of people usually have when they come to this event sourcing idea is, well, what happens when the data changes or the event changes, or a model goes away entirely or split into two different models? This is really a big problem if your domain isn't stable, which ours wasn't. We didn't really know the pieces that we were going to be building, so it was hard to know what the events were going to look like, so we ended up having to change them a lot. A lot of the ways that you can actually handle this is to use versioning for your events. So you have the original event as v1, and then as you create new versions of that event, you would version those, and that way the projectors and the model itself would know how to handle that, but it means it would have to continue to handle the legacy events forever. There's the idea of upcasting events. In some cases, you're able to take the legacy events, get the information to the point where it can actually look like the new event, and then replay that event. There's lazy upcasting, which is the same sort of thing, except that once that event comes back in and has been upcast, it is then stored back into the event stream. This is interesting unless you don't want to have your event stream be mutable. A lot of people are really big into their event streams not being mutable, so this really isn't a good option in that particular case. There's an idea of in-place migration. This would be going through as a distinct process and going through the entire, or all the events in all of the event streams within your application, looking for specific events and then rewriting them in place. The other idea would be to copy all of those events out and migrate the ones that need to be migrated and then move them all into a brand new event stream so that you don't have to do the things in line, so that your event stream no longer has to be mutable to do these kind of migrations. What we ended up doing was sort of an in-place copy migration. We would read through the event stream. We'd read through the event stream, clear the old event stream, and then replay everything into the original data store. So that was kind of a hybrid approach. Our hybrid approach required downtime in order for it to be safe. What it did afterwards was rebuild all the remodels from scratch. So originally, the only way that we could rebuild all our remodels was to completely rebuild the event stream with no migration. For the first month, it only took about 30 seconds anytime we had to do this, which we didn't end up having to do very often, but occasionally it would be like a couple of times a week. But it would take 30 seconds, so the app would have to be down during that time. By the middle of the second month, this started to become problematic. The number of events in the system was growing exponentially, and was taking up to 10 minutes just in the second month. So we really needed to find a better way to handle that. And best case would be not doing any sort of migration that way anymore. So we started to be more careful about the events and how we would want to handle changes to the events in that case. Replaying events broke on some changes, and some in ways that you wouldn't expect. Some of the things that we didn't originally think would be a problem was removing events. If we removed events from our code base, it seemed like that would be fine because we're not breaking anything, we're not reading it anymore, so it should be good to go. But of course, the serializer, when it gets that event out of the event stream, it can't find that class to unserialize it back to. So we would run into issues like that during our 30 seconds downtime that would end up taking hours to actually say, okay, well, we have to go back through and fix the migration or fix the replaying code to fix those. If events were removed, incompatible structures, we had some really fun ones where the serializer had a bug in it that in some cases it wouldn't save the data, like the ID of some of the relationships. So what would happen is the system would work the first time through, and the event would be sent everywhere when it was live, but once it was serialized, it lost the data, or it lost some of the data. So when we actually went back to replay those events later, it was no longer having the information it had the first time through. So yeah, that made for some really interesting data recovery when the source of truth didn't actually have the information, even though the read models did. After we figured out that we shouldn't be doing the migrations all the time just to rebuild the read models, we created a way to rebuild all the read models. That was the first thing that we wanted to do. This was sort of a nuclear option because it did rebuild all of the read models. So when it took up to 5 minutes to rebuild the read models, just because you changed the timeline view of one of the objects wasn't very good. We quickly went to the option of finding a way to rebuild individual read models. And this helped a lot because we were able to start doing smaller changes, which really, really helped. So some of the read models could rebuild now in 10 seconds, 5 seconds, 3 seconds. Some of the bigger ones, like the search read model, would still take 2 minutes. But we were now able to do rebuilds against the things that actually had changed, which was nice. The system was mostly optimized for read, which makes a lot of sense. That's kind of one of the big things between CQRS, or with CQRS, that you want to optimize for whatever purpose you're doing. So in this case, all of the read models were really fast to read, but they were pretty slow to write to actually build them up. All in all, this whole idea of being able to rebuild the read model sort of gave us a false sense of security because they eventually started to become pretty expensive. And a lot of that came in with like the reflections properties, Serializer I mentioned earlier, where all of a sudden these events, millions and millions of events were having to be serialized and deserialized. It started to show that there were going to be a lot of places that we needed to work on performance. We also had to start rebuilding the read model while the app was active. And this was actually mostly okay for the most part because the system didn't have a lot of writes. But we were getting to the point where we were getting more users where we couldn't guarantee or even have a good idea whether or not there were going to be a lot of writes at different times. We also started to get some weird side effects, which were actually fun to watch, but also, from the user perspective, not good. Because you really would have objects that would completely disappear from the read model if it's reading through the read model and it hasn't gotten to when it's been created yet. So it could even be missing in some cases, and other times it could have completely different names, it could have different attributes, all these things that might have happened. You wouldn't have that information yet, so you'd be looking at the code. Every time you reloaded the page, it would show you slightly different information. So we started to look into some solutions for that. One of the solutions lets you queue the events. So this is where you'd actually have to start decoupling the actual processing of the events from where you're actually generating them. So we'd have to start worrying about eventual consistency. You'd queue the events, so you would stop queuing them. So that you would queue them up and then stop actually playing them into the projectors. And then you could take all of the existing events, replay those into a new read model, and then you'd be able to swap the repositories so that then you could start playing the queued events back into the system. So this would be a safe way to rebuild a read model and then start building or take into account any changes in the system since you started the rebuild process. So this was going to be a really good solution. There's a couple of implementations. One of them was a follow store that sort of allows you to do this sort of thing, but we didn't actually get to implement it, which was a little unfortunate because I really wanted to get to this part because this really would have been, I would have felt more like I'd actually built an event sourcing CQRS system if it was actually doing these things asynchronously. We did a lot of fun things with chat apps. We were able to do all of the work that we need to do in the production and staging environments just through Slack. We were able to run the migrations. We were able to rebuild read models. We were able to look to see whether or not any of the read models needed to be updated. So if we deployed code that had changed, we'd be able to look to see that, oh, well, production has that code, but the model isn't updated yet, so then we would know we would need to replay those events for that read model. We also discovered this idea of private state. One of the problems that I ran into that I actually see a lot of places, but I haven't seen people talk about this yet, is that we were following too strict the CQRS idea that you don't put getters on your write model on the command side. So the problem was that we had no way to get the information that we were trying to compare against. So we ended up writing a bunch of read models to just handle the information so we could get it, even though we had the object with that information at the time. So this was something that I learned that I was following this too strictly. Would have been a lot easier if I would just ask that model for the information it had. But the solution actually turned out to be quite useful for a lot of other things. The idea of private state is it's just another type of read model, but it's only going to be consumed by a specific type of object. So for example, command handlers would have private state to be able to look at the information required to modify a model. Projectors would be able to consume private state objects so that it could update the read models correctly. So cases like this would be, say you have a timeline entry where all of the all of the events that come in have a user ID, and that's all they have. So you can't really create your timeline entry to say, Beau did this at 3:30 p.m. because all you have is my user ID. So one of the private state objects for this particular read model would be a private state that was just consuming user was created that had Beau in it with that ID so that we could map it, or username was updated, which would have my new username. So, and that's another thing when you're watching a replayed event model, you would start seeing things like that. Like if the username had changed, you'd see the whole screen would change from Bob to Robert, for example. We also started to use these private state objects for services as well, just because it became very difficult to manage creating specific read models just for these simple use cases that we couldn't handle otherwise. So the biggest takeaway I had from this experience was that it was going to be slower development. If you look at all of the pieces required to actually take something from adding a brand new element to a model all the way to at least one read model that's using that, there's a lot of pieces that get touched. I took this screenshot at one point. This was adding one new field to our application, and it resulted in changing 238 files and adding over 7,000 lines of code. I think this field was something that was very well used, like username or something like that, but it had to be propagated to everything that needed it. And so at that point, since that field was being used everywhere as some sort of identifier, all of those read models needed to be updated. Where I saw the biggest wins were search. Search was huge. This made our application more powerful than a lot of other more established applications really quickly because it just worked. Timeline turned out to be a huge win because we were able to make some really rich timeline models showing what was going on with our different entities and how they were related to each other really well. Retroactive features was nice, and this was really something that related to timeline as well. We were able to launch the timeline functionality about a month into our application's life, which meant that there was already a month worth of user data. And we were able to launch with several of the timeline type entries right away, which was great. And it was able to go back in time to show these types of entries because we had the information all along. And then as we kept adding new timeline entries to the different events that we had been creating, those would show up over time. So I would be able to see that maybe I called a contact and that wasn't originally on the timeline, but I did it 2 weeks ago. A week from now, when we deploy that functionality, I'll be able to see a line that says 3 weeks ago I called this person. So it was really kind of cool to be able to see this sort of promise of being able to look at old information in new ways. All in all, I think that the way that we built this application was pretty nice. It really allowed for some natural evolution on things. It may seem like we went way out of the way to do some really far out stuff, but we really did build a really modular system. We built it in such a way that we got it just as far as it would work pretty well, but without having to go all the way with it. So like, for example, the MySQL adapters for everything. We were able to just move on, and then when we needed to go back and optimize something, we'd be able to. As far as event sourcing was concerned, my big takeaway from that was that event sourcing makes a lot of sense if you have a really well-known and stable domain model. So accounting is an example of something that is probably not going to be very different. If you have somebody who has an ever-changing idea of how a CRM should be built, then your model is not going to be very stable. So you're going to be rewriting your events quite frequently. Figuring out how to handle that with a early stage application is not very easy. CQRS, on the other hand, was a really good fit. I thought that we were able to leverage that really well to do a lot of really great things. You're able to focus on the presentation of how you want the data to be handled, completely separate from how the actual write side was being done. So even if you weren't going to do event sourcing, if you wanted to try and build something with CQRS for a quick project, it might actually be a good way to go. But it does come at a cost. The CQRS stuff, especially if you're building all the way from like the command bus up, you are going to end up with a lot more files on the system and a lot more moving pieces. I'd say what we did was we built our own. I'd say if you can find something off the shelf, might be better. At the time, the only real mature library was Broadway. But I really didn't like the way that the read models worked with Broadway. I think Proof was probably in existence at that time, but I don't think it was as mature as it was. I think the big things to look for would be an event store. Make sure that you can find an event store that works really well for you. Test harnesses for this kind of system are really great because dealing with events is different than you would be dealing with normal things like within PHP unit. So make sure that the event system that you're using has a really good way to test things. And then make sure it's a good fit. Like for us, Broadway would not have been a good fit because the read models were pretty restrictive. It's all based on Elasticsearch, and that was the only shipping implementation of the read model. It felt very limited, so it didn't really seem like it was going to be a good fit for us. At the same time, I'd been writing some CQRS tutorials for people and giving them at conferences, so I knew that it was going to be relatively easy to build the read model part anyway. So I really didn't see a lot of benefit to going with something off the shelf at that point. And it turned out to be a great investment for the team. The people that I was working with learned a lot. We learned how things work together. And I think it made the whole process a lot better. That said, I don't know if I'd make the same decision today. The landscape has changed a bit. Proof is far more stable now. It's more mature. More people are using it. Broadway is still as mature as it was before, and people are still using that in production. So it might be possible that one of those systems might be better for people. But it did work. It was just a little slower to actually get things done than we'd hoped for. If you want to do something like this, it would be important to get support from management, whoever's in charge of things, because they need to be aware that it is going to come at a cost. I had that support initially. We wanted to build this as a solid system. We knew we were going for big data. We knew we were going for accounting. We wanted to have a really good system in place. But we had some real unrealistic expectations and mismatch, even in what it means to be an MVP versus not. Eventually, it just became a feature race. And feature race with event sourcing and CQRS is not a race you want to be running. Eventually, he really just wanted everything in CRUD. He wanted table outputs, and he wanted click this, edit that, be done with it, and our system just couldn't do that. So really the pivot changed everything for the project. Everything around the technology, everything around the business angle of it really changed everything. And so in the end, we couldn't sell the MVP. So if you can't sell the MVP, and it takes you 6 months to find that out, after it took you 6 months to build it, it's possible that might not be a good choice to try and use event sourcing and CQRS in those cases, unless you're already invested in most everything else in the application. For example, the proof team could probably build a really nice event sourcing CQRS MVP because they live and breathe it every day. But I think that if someone else is looking at trying to do this from scratch and build an MVP, probably something you might not want to do without seriously thinking through the consequences on it. So that's the story. I don't know if we have time for questions or if that's a thing we do here. Might not be. No questions? All right, cool. All right, well, thank you very much.